So look, here's the simplest quadratic there is, right? So this is quadratics number 19, the discriminant. That's going to be today's topic. But to warm you up, this is the simplest, okay? We'll do it off to the side. F of x equals the very simplest quadratic you can do. Want to try again before I do it? It's got to have this. That's it. It's x to the power 2 that makes it a quadratic. Are you with me? Can you remember that? That's your simplest quadratic. Because if you go into Desmos right now, which maybe you should do, open up Desmos because I bet we'll use it today. So I told you to close all your screens. Open your screens and go to Desmos. Oh man, it's like a whiplash, right? Go to Desmos, do f of x equals x squared, and see what shape you get. F of x equals x squared. Go quickly. Are you going to Desmos quickly? Are you going there quickly? Are you going there fast? Yep, then type in f of x. Whoops. Jumped. Right? What shape, Nikki? What shape? What shape you guys get? And that's the most basic, right? You're getting the shape, this shape here, right? What's it called? Parabola or parabola. How do you make it upside down? So go right into your formula and put a negative in front of the x squared, right? And what happens to your parabola? Now it's going like that, right? This is a smile. This is a, and notice that the frown is negative. Will that help you remember it? All right, that's your most basic. Now we're dealing with a trinomial because we're taking the two binomials and multiplying them, right? We go from the FOIL method, we produce the trinomial, then we go back from the FOIL method, we factor, and we use three methods for factoring. We use just a straight, sort of guess and check factoring method. We used a completing the square factoring method, and we used the magic quadratic formula, okay? I don't expect you to remember the quadratic formula. Did anybody do the competition to see if you could say it quickly? Anybody do that? No? Okay, fair enough. Always fun, but we got distracted by other things. So here's the quadratic formula. X equals x because we're talking about roots. Roots are where it crosses the x-axis. We'll talk about that more in a minute. X equals negative b plus or minus radical b squared minus 4ac all over 2a. That's the quadratic formula. You can solve for the roots of a parabola using this formula. It's one of the factoring methods to get back. So let's talk about roots again. If this is the x-axis and this is the y and the parabola goes like this, how many roots do you have? Yes, somebody's holding this up. Why? It crosses the x-axis here and it crosses here. Those are two roots. What's another name for roots? Zeros. Good. Another name? Zeros, roots, and one more name. It's kind of like in football when they're passing the ball and somebody's going to catch it, but X intercepts. It's an interception, right? Is what I was trying to do in football, right? And that's where the two paths cross. Okay, so that's your names. How many roots or intercepts, x-intercepts, or zeros are there in this one? How many roots? One, just like it looks like, right? Don't trick yourself too much. I mean, it is what it is. Two here, one here, right there, right? And when you type this in, wasn't it touching right here at the x-axis when you typed in x squared for the most fundamental basic quadratic? You okay with this? 2, 1, where am I headed? What happens here? And the way you have to say it, there's a special way you have to say it. Ready? You have to say no real roots. Say that. Say no real roots. Because there's imaginary roots, and you're going to do imaginary numbers next year in Algebra 2. Did you know there's such a thing as imaginary numbers? There are. And they explain the roots of a parabola that's up above the x-axis. Fair enough? All right. So let's get back to the discriminant. The discriminant is a piece of the quadratic formula. It's this piece under the square root. So what is the discriminant? And it's not the word, you know the word discriminate, right? Discrimination. Discriminate. It's got the word Nate in it. My first name's Nathaniel. You can call me Nate. Do you know this? Somebody named Nathaniel, you can call Nate. You know people named Nate? Okay, that's discriminate, right? This is discriminant. Everybody say discriminant. It's a special word. It means this piece right here. It is, the discriminant is b squared minus 4ac. We're pulling this piece out of the formula and we're using it to determine how many roots a quadratic has. Here's the first example. Let's try it and see if you can figure out what we're doing. The first example is x squared, bless you, x squared plus 6x minus 27. Bless you. This is f of x equals x squared plus 6x minus 27. All right. How many roots does this parabola have? First of all, what are your options? What are your options? Hold up fingers. How many? How many? How many? There's none of these, right? There's no, it's only this, this, or this. You with me? That's your only options for roots. You've got 2, 1, or 0. So how many roots does this have? We're going to figure it out before solving the whole thing. We're just going to determine how many roots right off the bat. So we're going to use the discriminant. We're going to say the number of roots equals b squared minus 4ac. Where does this come from? It's a piece of the quadratic formula that's under the square root symbol. Tell me what a is in this case. I heard somebody say 1. You with me? You see why it's 1? Okay. What's b? What's c? Okay. And we've got b squared. So 6 squared minus 4 times a times c. You okay with that? Did I fill it in right? What's 6 squared? So let's do this part. 4 times 20 is 80, and 4 times 7 is 28. So that's 108. Does that make sense? Okay, and it's negative times a negative. Positive 108. You okay with that? And I want to follow my example from the notes. Okay, so far so good. Well, this becomes 130 and the 6 plus 8. What 6 plus 8 is 14. So 144. You okay with that? All right. Now how many roots? So here's the way it works. If this number is positive here, under the square root symbol, 144 under the square root symbol, if it's greater than 0. So if the discriminant is greater than 0, right? Is 144 greater than 0? Ding. Good. You're going to have 2 roots. Fair enough? Okay. What are the options for the discriminant to come out next? What are your other options? What else could the discriminant be? If greater than 0 is one option, what do you think are the other options? Less than 0, good, which would be what kind of number? Negative number. You follow me? If the discriminant comes out a negative number, that's an option. What else could it be? This is greater than 0. You said less than 0. What's one more option buried right in the middle of that? It's greater than 0, less than equal, or? Yeah, trust yourself, you guys. Equal to 0, right? The discriminant can be greater than 0, equal to 0, or less than 0. Good enough? And these are the 3 options. And the 3 options correlate with 2 roots, greater than 0, 1 root if it's equal to 0, and no real roots if it's a negative number. But think about that. Can you take the square root of a negative number? No, not in this class. You're going to need imaginary numbers to do that. You actually can, but we developed a system called imaginary numbers to take the square root of a negative. You don't know it now, so you're going to say no real roots. It's going to be up here somewhere. The parabola is up above the x-axis. There's no roots. Okay, so here are your other options. Let's put it all in a list. Discriminant equal to 0 is 1 root, and the discriminant, I'll write it each time I guess, is less than 0, no real roots. Fair enough? You kind of see the system emerging? And so your whole idea is I can analyze the parabola without solving the whole thing. I don't have to solve the whole quadratic. I can just tell you how many roots. And it's kind of a fun exercise because it plays into if you did solve the whole thing, now it makes more sense, which we've done before with the quadratic formula already. So let's do another example. I think I have one of each. This one is, cannot see it. Okay, negative 4x squared plus 12x minus 9. All right, let's tell me what A is. Good, negative 4. I appreciate you keeping the negative. That's exactly what you need to do. Please and thank you. Okay, that's right. That's the right way to go. What's B? What's C? Good, keep the negative with it. Keep that sign with it. It belongs to it. Okay, so fill in the discriminant, which is b squared minus 4ac all over 2a. B squared minus 4ac. Sorry, I'm repeating the whole formula. B squared minus 4ac. What's b squared? 12 squared minus 4 times a, which is negative 4, times c, which is negative 9. Look at all those negatives. Negative times a negative times a negative. What's it going to come out? Positive. Careful. It's now positive. Why? Because what's a negative times a negative? That is a positive. But there's another one. So now it's positive times another negative. You with me? So it switches back. Are you okay with this? Okay. So there's a minus in here. What's 12 squared? Are you saying 144? Yes. Okay. Now, let's try to do this. 4 times 9 is 36. 36 times 4, 3 times 4 is 120, and 4 times 6 is 24. Does that come out 146? Help me out. Why is my brain not working? No, it's 144. Yeah. Why is my brain not working? I'm sorry, you guys. 144. I should have eaten my Wheaties this morning. Okay, so what's 144 minus 144? 0. Okay, thank you. And so look at how it matches up here. The discriminant is now equal to 0. How many roots can we expect? 1 root. Okay, so this is going to be one of those parabolas that comes down right here. In fact, it's negative. So this one's going to be, upside down coming in right there and touching that x-axis in one place. Doesn't cross over, doesn't stay under, it's right on it. Right on that line. So 1 root. And one more. Let's do a negative. So f of x equals x squared minus 3x plus 4. X squared minus 3x plus 4. We're going to go straight to, A, B, and C. What's A? 1. What's B? What's C? 4. B squared is going to be negative 3 squared minus 4 times A, bless you, times 4AC times 4. There we go. What is negative 3 squared? What's negative 3 squared? What is 3 squared? careful, it's 9, right? Your brain's going to want to say 6. Why? Because you see the 2, you see the 3, your brain goes 3 times 2, right? But it's 9, it's 3 times 3. Okay, so 9. But what happens if it's negative 3 times negative 3? Positive 9, same thing, right? It cancels itself out. So we've got 9 minus 16 equals negative 7. Do I have that right? Check my math, please, because you know me, I just start winging it. What's our number? Negative. So our discriminant came out negative. If the discriminant is less than 0, and this is an elegant way of saying it, right? To say something is less than 0 versus it's a negative number. This is a little bit more mathy, right? A little bit more elegant. Math people have this word called elegant. They say there's an elegant answer, and it's kind of like we're so happy with ourselves. We like it a lot, right? Which I agree. Over the years, I've come to appreciate elegant answers. So less than 0 means negative numbers. This one's negative. There are no real roots to this. No real roots. All right, and that's one of those parabolas. It's going to come down. It's up here somewhere. Right? It's not crossing. Yes?
If b is negative 3, why is it 4?
One more time.
If b is negative 3, why is it 4?
So I'm trying to do, I'm not with you yet, but I might be here in a second. I'm trying to do b squared minus 4ac. Did I fill that in right? So b is negative 3 here squared minus 4 times ac. Am I doing it right? A is 1, c is 4. Is that okay? Are you looking at a different place?
Yeah,
Okay, is that okay? Did I do it right there? Okay. I start to wing stuff, so I appreciate you asking very much. Okay, so thank you very much. The more times than not, it's like sometimes when you guys, I start calling your names and I just start making up stuff, right? And I'm sorry for that. So, okay, thank you for that. So this is the discriminant, number 19. Stop that one.